So this video is about piecewise functions. So I thought I'd do a video on this just to give a little review, a quick review on what they are. Sometimes students seem to find these a little bit scary. I don't know why. So what are piecewise functions? They're just functions that are split into pieces. So if we look at this picture here, I see that I have, it looks like 3 pieces to this function. So part of it is a line when x is less than or equal to -1, and then part of it is a parabola here, and then part of it is another line. So it looks like it's a function made up of 3 pieces. And so how do we graph piecewise functions? Well, we're just going to graph each piece. So graph each piece separately. Okay, and then we'll be able to see what the domain and the range is on each of the functions. So let's see some examples. Okay, so my first piecewise function, so this is what it looks like written in function notation. So h of x is equal to x squared, so a parabola when x is less than or equal to 0, or the line y equals x when x is greater than 0. So if I were to graph this, I know the first piece of my function is a parabola when I have x is less than or equal to 0. So anything on to the left of the origin is going to look like a parabola. So if I remember back to my original parent function, I would have this parabola like this. Okay, but here in my piecewise function, I'm only the parabola when x is less than or equal to 0. So I'm just considering this piece of it here. Okay, and then from when x is greater than 0, I'm going to be just line y equals x. So again, I know the line y equals x looks like this. Okay, but I'm just considering the part where x is greater than 0, so I'm going to cut that piece off. And let's do it in pink to show that it is all, in fact, one function. Okay, so that is what my piecewise function would look like. So it's a parabola to the left and then a line on the right. So maybe I should even make this a little bit more, should look a little bit more curved like a parabola. Maybe that's a bit better. Okay. So the domain on this function then, well, I can see that I can choose any value for x. It's not going to be a problem. So my domain is going to be from -infinity to +infinity. And my range is going to be from 0 to infinity. So I can go as low as y equals 0, and then I can go up as high as I want on the y-axis. Okay, let's see another example. Okay, so sometimes we might have points of discontinuity in piecewise functions. So this will come up a lot in Math 1500 in calculus if you do that. And you'll learn about discontinuity and limits and things like that. So let's just graph this one and see what's happening. So I have the line y equals 2 when x is less than or equal to 1. So I know the line y equals 2 just looks like this. But I only want it for x is less than or equal to 1. So I'm going to take this off here, and then I'm going to put a solid circle there because I can include 1, x equals 1, on this part of the function. And then for x value strictly greater than 1, I'm going to be the line y equals x. So again, that just looks like this here, but I only want the part of it where x is greater than 1, so, and strictly greater than 1. So then what happens there at x is 1, I'm going to put an open circle because I'm not including 1 on this portion of the piecewise function. Okay, so then this here, this is what you'll talk about more in calculus, this point of discontinuity, this is jump. But for my domain, I'm going from -infinity to +infinity. I can include every value of x. It doesn't matter, and that jump is included, so the value x equals 1 is included in the function because remember this whole thing is the function that we're talking about. And then the range, the lowest value for y that I can go is 1 but not including 1, so it's going to be from 1 and then up to infinity. Okay, that's it. Thanks for watching. Good luck with the assignments.